So there's been a lot of discussion here locally about how to grade everybody during this time home from school. So we here at TMR, the Math Wizard, called in some of our other local wizards just to consult to see what they think. So I don't know, Gandalf, what do you think about how any kind of message for these students about grading? Gee, Gandalf, I don't know. That sounds a little harsh to say that they're not going to pass. Do you want to rethink that? Are you sure? I mean, really, what do you want to tell these students? I don't know. Sorry, guys. You heard the wizard. He seemed pretty emphatic. We'll continue to talk about it, but I don't know.
Okay, so algebra 1, this is the answers to the practice quiz from 8.6 to 8.9. I would have emailed you probably already a PDF with some notes and explanations and written things, but I figure sometimes seeing it happen may also help, so I have a smattering of these problems on the board. So number 1 is a thing called mixed expressions, because there's one with a fraction and one without. So what we need to do for these is make this one a fraction and make it have the same bottom. So since this has an x on the bottom, we need to throw an x on this bottom. And if you're going to change the bottom, you have to change the top. And this ends up being a 3x plus 4, because those are unlike and can't really add on top of the x that was dictated by that one. This problem's about the same. This is invisibly on top of a 1 that you could write if you want to. But in the long run, since this has an x, this needs an x. And if you're going to throw an x on the bottom, you need an additional x on the top, so it's x squared. When we go to do the answer for this, the x was determined by this to be the bottom of the answer. Nothing up here is going to be like terms, but take notice that this is going to switch all the signs to its right. So 2x squared minus x minus 1. This, same scheme in play. This is the bottom. That forces the other thing to have the same bottom, which forces it to take that also on the top. When you go to do the answer, the bottom that we saw all along, we know that's going to be the bottom. We need to distribute here to get 3c squared plus c. These c's are like, so we have 3c squared, a 2c from putting them together, and a minus 1. If that's not enough, maybe check the 8.6 video again. There was a whole bunch more stuff on that. This group is from the 8.6 part 2 video. Complex rational expressions have fractions in other fractions. This is just like what we got done doing in the most recent video on 8.9. So we pick an LCM. So we look at the bottoms, we see x's and we see y's, so we take x, y. And then we attack all 4 areas of this problem. This area cancels x's. The job of the circle is to cancel the bottom. And whatever's left over multiplies the top. So x cancels x. Left over y multiplies 1. In this area, y cancels y. Left over x multiplies 1. In this area, x cancels x, left over y multiplies 4. And in this area, y cancels y, and then the 4 multiplies the x. In some problems then you're done, but if you can factor, we like to take out a GCF. The top is invisibly in parentheses and can cancel, and that gets us a 1/4 grand total. 5's about the same. We see x, we see y, we see x, we see y, but we also see 3, so we need to take 3, x, and y. Here the x's vanish, 3 and y multiply 5. Here the y's vanish, so 3 and x are left to multiply 5. On the bottom, 3 and x vanish, so y multiplies 1. Here, 3 and y vanish, so 1 multiplies x. On top, you can take out the 15 to let you cancel, and the answer is 15. For 6, we'd use y plus 3, because the y plus 3 is all that we can see on the bottom. So y will need to distribute this for y squared plus 3y. Perfect cancel here, just leaves a 3. 1 times this is y plus 3. This cancels and leaves us a 1. The only thing you can really do to clean that up, 3 and 1 makes 4. If we could have factored the top, we would have, but we couldn't, so we don't. And that's the other half of 8/6. So there's 2 halves of 8/6. 8/7 starts at 7. This is dividing by a thing called a monomial, and we want to just divide that into each thing. 2 divides into all the numbers to make 2, 3, and 4. And then the powers we subtract. There's an invisible 1 there. So this x has a 3, this x has a 2. I'm just going to copy the signs, and those have no x's. Likewise on this, we do the same thing. We attack all 3 of those items. The minuses aren't going anywhere. Okay, but 3 into that is 3. 3 into 6 is 2. 3 into 3 is like a 1 if you wish, but we could maybe leave that invisible, we'll see. X's, subtract powers, there'd be 1. Y's, there's 2. In the middle, X's are gone. Y's, there's 1. Here, if you try to subtract the X's, there's 1 more on the bottom, so I'll do an X underneath. And Y's, there's 1 more on the bottom, so I leave a Y underneath. And that's like half of the 8/7 lesson. The other half of the 8/7 lesson is long dividing, so you'd want to recopy these with the long division kind of style box. The first thing I wrote in parentheses goes in, the second thing I wrote in parentheses goes out. So just like when you long divided in your youth, if you were taking like 21 into 897, your start would be to just think about 2 going into 8 goes 4 times. You just look at the beginning when you do that. So we look at these beginnings, and when we divide, that's going to be an x, because we're subtracting powers. Just like your youth. Once you decide what's up here, it multiplies it the whole everything to get you something like 84, so that you can, in a minute, subtract and drop a 7. So this has to multiply both of those, x squared minus x, so that you can subtract. Subtracting will wipe out the first one. We're subtracting in our mind a negative. There's a little minus minus makes plus going on to get negative 4x, and we drop that. And then we go again. Like in this world, we would take 2 into 5 goes twice, and we go again. This dividing this is a negative 4. Negative 4 multiplies everything. We would try to subtract. There's no remainder, so we're good. For this, same kind of thing. Divide the liters as 6x. Multiply everything. 6x squared minus 18x. Subtract. When you subtract, this will become a plus, because we're subtracting a negative. So 11x, and always drop this. That never changes, it just drops. Divide these, it's positive because they're the same type, 11. 11 multiplies everything, 11x minus 33. When we go to subtract, that becomes a plus to get 37. With the remainder, we throw the 37 on top of the original x minus 3. The last one of these is the meanest because I went out of order and I skipped some stuff. So when I wrote this on my board, I recopied for the 3x cubed as the highest power to go first. I left some spaces for where x squareds and x's might one day be, and shoved the plain old number to the very end. So divide the liters, 3x squared, multiply everything, 3x cubed minus 6x squared. Subtracting will make any negative on the bottom row become a positive. But the top row never changes, just break. Go again, dividing these is plus 6x, which multiplies both like a distribute problem, 6x squared minus 12x. A minus from the bottom becomes positive. Likewise, a positive on the bottom would become negative, but we haven't had that happen a lot yet. Drop to plus 6. Divide these, that's 12. 12 multiplies everything. When we subtract, again, that's a switch to be a 30, so remainder of 30 on top of x minus 2. 12, I didn't see a need to do on the board. Just put the first number over the second and reduce. 30 over 45, reduce it. 13, you can't do it if the units are bad to each other and mismatched, so make the 10 yards be 30 feet, because 3 feet makes 1 yard. So 10 yards times 3 is 30 feet. Put 4 over 30, reduce. 14, 10 millimeters make 1 centimeter. So make the 2.4 a 24. Put 24 over 30, reduce, and we'd have that one. That went 2/3, 2/15, and 4/5. 15, just cross multiply. 12 times 20 is 240. 14 times 18 is not 240, so no. It was 252, we're just looking for agreement and it does not. 16, go 12 times 75 is 900. 25 times 36 also is 900, so yes, true on 16. 17, we continue to cross multiply. Cross multiply means you multiply these guys, that's 7x. You multiply those guys, the diagonal ones, that's 168. And then you do opposites. 17 is 24. 18, if you cross multiply, 180 times c equals 180. Do an opposite, dividing 180, so you get 1. 19, if you cross multiply, the 20 has to distribute, so 20x plus 20 equals an 80. Do some opposites, you get a 3. 20, you'd have to have 8 distribute x plus 7. You would need 16 to distribute x plus 3. Do some opposites, that would turn out to be 1. I wrote that all out on this paper. I don't think that probably needs the big explanation, and I'm running out of board space anyhow. 8-8 notes, that whole page from 12 to 20 was like the 8-8 lesson. 8-9 is the last thing from 21 to 25. We're basically back to the circle thing idea. So we look at the bottoms and we see x's, multiply everything by x. The circle's job is to cancel the bottoms. If there's leftovers, it multiplies the other pieces. So x's cancel to leave a 1. X's cancel to leave a 3. 12 multiplies x. And then you just combine like terms and do stuff. 4 would equal 12x. Divide by 12, because 12 is with the variable. 4 dividing 12 is a fraction, reduces to 1/3. This, we look at the bottoms, these both go into 6. So 6 times 4 is 24. 6 canceling 6 leaves 10x. 6 canceling 3 leaves 2. To multiply the other 2, and that's a 4. So subtract 4 to get 20, divide by 10 to get 2. This 3, 2, 4 all go into 12, but we also need an x because we see an x. Anything you see, you take. So x's cancel, 12 cancels 4 to leave 3, to multiply the other 3. Here, 2 cancels 12 to leave 6, but also x is there. Times 1, that is a 6x. Here, x's cancel. 12 cancels 3 to leave 4, which conveniently multiplies another 4. That's just a coincidence. 4 times 4 is 16. So subtract 16 to have -7. -7 ends up on top of a 6 as a fraction. This, you'd have x plus 5 is the only thing you have on the bottom. So when these cancel, you leave an X. 5 distributes X plus 5. So 5X plus 25. Here from this cancel, we'd be left with a 5. Like terms to make it 20. I'd subtract 5X to get that out of there to get 1 minus 5 is negative 4X. Divide negative 4 into this, and we'd be getting negative 5 for a moment, but one problem on this problem only on this page. If you try to put negative 5 back in to check it, negative 5, adding 5 would make all of those bottoms be 0, and you are not allowed in math to have bottoms equal 0, so that one flames out. The last one I ran out of space, but we use X minus 3 to do the cancel, that would be our circle. You would just end up with the tops. 2X plus 4 would equal 6X. The tops are all that would be left. Do a little bit of opposite work, we'd end up with a 4X equals a 4 from subtracting the 2X, and the best answer off of that will be a 1. Hope that's helpful. Between the notes that I'm sending you with PDF email and that, hopefully that's good enough for you. If that's not enough, by all means, please email me or jump in on the next Zoom session and we'll try to work it out. See you next time.